Okay, everyone. All right, everybody. So, hope everybody's doing okay. So, another video on, let's say, the average rate of change. Now, this is a little bit different than the difference quotient that if you looked at the difference quotient. But the rate of change says that I have some two points, and I want to find the average between them. So this is kind of what I would like you to do. So average rate or average rate says that if I take a graph like this, and I want to maybe draw something like that. And maybe I'm kind of going along this graph, and I start here, and maybe that goes right there. And then along the graph, I'm going to go there. So think of it like the average is you add them all up and you divide by so many. That's what average is, right? It's like the mean. So it's kind of like the median, or I'm sorry, mean or average in statistics, where you add up all the numbers, divide by how many you have. The average rate is very similar to that. So you want to kind of look at this. So it says that, well, let's say I call this A, and let's say I call this B. So I have my function, and I'm going to say, hey, if at this point, I'm going to call it A. And you're probably thinking, well, can I just call it X because this is the X axis? Yeah, but think of it that you want to kind of understand what you're doing. And I'm not trying to make this confusing at all, but if you think of A as like the start of the alphabet, or X sub one, whatever you want to do, and then B is kind of like the end of the alphabet where you go into A to B. Okay, so you're going A to B. Okay, that's kind of like what you're doing. Well, I want you to think about this. If this is the y-axis, or maybe you want to say my function, because technically this is a function that we are looking at. These are functions. It's a terrible looking function. Function. All right. My pen is kind of blurry there. So think about this. If this is A, what is the output on A? Well, the output of the function is going to be f of A, right? Because you have an input, you have an output, because you have the function f of x. Well, if you go over here, this is B. The output is going to be what? F of B, right? Because remember, you're doing an average rate. You're kind of traveling along this distance to this point there. So now you have this point and this point. Well, think of the average rate as a slope, because that's what that is. An average rate says what is the slope, or what is the distance with this movement. You can call this time. I mean, this could be time, this could be distance. Think of it that way. Okay, so here we go. Remember, you need slope. So let's look at the first point here. I have A, F of A, right? That's the first point. So if you don't like that, call this A sub 1, Y sub 1, because remember, like a point on a graph. Then what's the next point? Well, the next point is going to be B. And what's the output? Well, that's F of B, or F of B. X2, Y2. Well, do you remember how to find slope? Well, slope is going to be y2 minus y1, x2 minus x sub 1. That's your slope, technically, right? Well, let's go ahead and do this. What is y2 in this case? Well, y2 is that. So you're going to go f of b minus y1. Well, y1's that, which is f of a. Okay, this is x2, which is b, y, or x1, which is a. There you go. That's called the average rate. Sometimes you can kind of look at average rate of change. It's kind of like an acronym ARC, if you think about it. So that's a little bit different than the difference quotient if you looked at that video. Um, let's do one of these and maybe it will make sense. But we want to use this equation for the average. So let's look at that. So let's say, for example, we want to find the average rate. So let's say average rate of change. You want to find the average rate. And let's go ahead and use a function. So this is our function. And let's say our function is going to be, let's try to make one a little easy for you. So what if we use x squared? This one's very easy because this is a parabola opening up at 0, 0. So if you want to know the graph, it looks like this. Okay. Now what I want to do is kind of what is the rate of change of some intervals. So let's say that of this over the interval. Let's say I want to say something kind of cool. What about 1 to 2? What about just 1 to 2? But what I want you to do, we're going to change this up because I want you to kind of see this is kind of cool. So we're going to do this and we're going to change this up a little bit. But let's go ahead and do this real quick. So we want to find the average rate of change of the parabola opening up from 1 to 2. So you should know what 1 to 2 is. I'm hoping that you kind of see it's kind of about right there. So that's kind of like 1 and 2. It's this rate of change. So just go back to the equation. So go back to that equation that we just had. It's f of b minus f of a, b over a. So that's the average. Now, I don't know if you remember what to do here, but let's go ahead and call this like A and B, right? Because technically that's the first, that's the second, if you think about it. So let's go ahead and use those in the equations. So here we go. There's always going to be a minus sign, always a minus sign. On the bottom, B minus A, 2 minus 1, 2 minus 1. F of B, do you remember what this is? That's f of x, but they put a b. So if you take this value and insert it into this function, what's the output? Well, isn't that going to be 2 squared, which is 4? So that 4 is the output of there. What's the input here? Well, the input's 1. If I take that 1 and put it into this function, I get 1 squared, which is 1. And that's 1. Well, there you go. So now go ahead and do some work. 2 minus 1 is 1. 4 minus 1 is 3. So it looks like between 1 and 2, you have a slope of 3. Now, you should put these in words, but we're going to do that later because that's the part we need to explain. But this is the math part of this. So from 1 to 2, the slope is 3. Now, if you think about it, everybody, if you draw this a little bit more carefully, that between 1 and 2, doesn't that look like you have a slope of 3? Doesn't that look like you have a slope of 3? Yeah, it looks pretty convincing. I'm convinced. Well, remember how I kind of want to change this up a little bit, just kind of see what's going on? Well, let's do the same with f of x equals x squared. But this time, let's go from maybe 1 to a little bit closer to 1. So what if we go to like 1.001? We're going to get very close to 1, but not quite get to 1. We're just approaching 1. So you're going to do this again, kind of a function. And then remember, this is kind of like your A, this is your B. And we're going to follow this function up here. Hope you can see this. This says that I'm going to go from B to A. I'm going to go from B to A, and I'm hoping that you can figure this out with a whole lot of calculator. But if you need a calculator, just go ahead and go, okay, 1.001 minus 1 to just make sure that you're confident. And if you're not confident, well, that's okay. Mine's a scientific notation, but I can change that. So let me but anyway, you should know what that is. I'm not trying to make this a big deal, but this is 0.001. I'm just trying to make that convincing. So you can do this in the calculator if you doubt your mouth. Okay, so now here's what we're beginning to have some fun. We're going to take this number and we're going to put it into this function, right? Because isn't that what that says there? It says take this input and put it into that function. So you're going to go ahead and go on the calculator. And you're going to go parentheses 1.001 squared, and then you're going to go ahead and push enter, and that's the answer for that. So that's 1.002001 minus, well, if you put 1 into the function, isn't that just 1? Yeah. So this is 0.001. What is that going to be? Well, if you can't do that, just hit subtract 1, and it's that number there. You can't see that there. So that's going to be 0.002001. Now, take the calculator and go ahead and do all this. So just take your answer and just hit divided, hit dividing. And what you're going to do is say, once you hit division, you're going to go ahead and put 0.001. And there it is. Looks like 2.001. So the slope at that point is that. Okay? So look at this. This is so cool. We jumped from 1 to 2. We got a slope of 3. We went from 1 to almost 1. We got a different type of slope. So that's very interesting. So that is very interesting because look at these slopes. As we get closer and closer to 1, our slope gets closer and closer. It looks like 2. As you move on to calculus, you're going to start figuring out why that is. And it's so cool. All right. Hopefully that made a little bit of sense. And go ahead and think about that and let me know. All right. Thank you.